our last one is a sphere. And so we're going to be talking about finding the surface area of a sphere. So first let's talk that a sphere is the set of all points in space equidistant from a center point. So here's our center point, and the distance from this point to every point in the sphere, going either sideways, up and down, they're all the same. And that's what makes it a sphere. So the radius is the distance from the center to any point on the sphere. That means from the center point I can go to here, and that's going to be the same distance as from the center point to there, from the center point to over here, from the center point to clear over here, I guess, yep. From this to that type of thing. So any direction, I guess it would make more sense if we draw this all the way, to any place on the sphere. And really, that can be any portion of the sphere as well, not just our little black lines. And even though it wouldn't look like it, that's the same distance as from here to there, but that's just because the way we draw the picture itself. Right? So when it comes to finding the surface area of the sphere, the book goes into this long drawn out about how it's the lateral surface of the cylinder. If you really want to know how they came up with the formula, come find me. I'm happy to tell you. But what you need to know is that the surface area of a sphere is 4 pi r squared. Ta-da! Alright. Again, if you want to know the real reason where that pi r squared is obviously a circle. So figuring out where the 4 comes from, come see me and we'll talk through what the book has. But I don't want to get us too confused. So, knowing that, 4 pi r squared, then I go into a problem which could have a picture. In this case, we don't have a picture. We're trying to figure out, to the nearest square centimeter, what is the surface area of a bubble with a radius of 3 centimeters? So just like before, I always write what I need. So to find surface area, I just need the radius, and our radius is 3. To find the surface area of a sphere, it's 4 pi r squared. So we're going to have 4 times pi times 3 squared. And then I just start simplifying. 4 times 3 squared is 9, so we have 9 pi. And 4 times 9 is 36 pi. So right now this is our answer in terms of pi, in case you Math Excel asks you to give an answer in terms of pi. This is what it's talking about. And then I'm going to take that 36, I'm going to take it times 3.14 because that's what Math Excel is wanting us to use. And when I do that, I end up with 113.04 centimeters squared. Now, I've got to be careful. It tells me to the nearest centimeter, square centimeter, which means no decimals. So when I go to round this, behind the 113 is a 0. So this is approximately 113 centimeters squared. That is the approximate surface area of the bubble with a radius of 3 centimeters. And that's how you find the surface area of a sphere. Before we leave, just so that they're in one place, I have this nice table for us. So we talked about cylinders today. So if our shapes are a cylinder, our surface area is going to equal 2 times the area of a circle, so pi r squared, plus the circumference, 2 pi r, times the height of our cylinder. We talked about cones in this section, and so the surface area of a cone, we only have one circle, so that's pi r squared, and then our lateral area is pi r slant height, so pi times the radius times the slant height. And then our last one is the sphere, and so the surface area equals 4 pi r squared. And that is all of your formulas that you will use for this section. So until next time.